let's discuss in this video system design of WhatsApp mobile application, its scalable architecture, diagram and key components. So WhatsApp is one of the most widely used messaging platform, handling billions of messages daily. Designing such a system requires careful planning around scalability, reliability, low latency and real-time communication. So in this particular video we will break down high level architecture, core components, message flow, database design, scaling strategies and system design diagram. Okay, so let me first show you the high level architecture of WhatsApp application. So basically this particular this design basically having components: mobile client like the iOS or Android application, then web sockets, load balancer, chat servers, presence server and cache. Then the cache is also part of presence server, and then messaging queue and database. So we will discuss one by one. So this is the diagram, like how the whenever someone, let's say user A wants to send message to user B, and that proper communication takes place with that communication follows this particular architectural flow diagram, like how the communication starts, then that request sent to the web socket. So web socket will handle the APIs to get the message and send it to the user B, and load balancer basically distributes the loads among servers. Then chat servers are taking care of the message sending and receiving. Presence server will taking care of the status, and cache will keep the recent charts and all. So that and message queue like Kafka and RabbitMQ, that will take care of the message queue. And because here we'll be using more, because every day there are billions of messages has to be sent from across the users, so it need a NoSQL database, so that will handle high throughput of data. So that is why it will be preferring NoSQL database, that is Cassandra. So okay, so this is actually the a high level overview of the design, like how the WhatsApp works. Now we'll be understanding each component one by one, how it works. This particular video is basically just to get the overview of high level to understanding of how the WhatsApp application architect and how the system design of WhatsApp. So let's understand one by one components. Okay, so there are basically, before going to the component part, we'll be understanding two things. One is functional requirement and non-functional requirements. So functional requirements means the objective of the application, that is one-to-one messaging, group messaging, media sharing. Like basically in the in the WhatsApp we are able to send the images, videos and documents and all. We can do group messaging. So there can be I think there is a limit of 200 people one group can have, and people can message to and fro in the group, and one-to-one messaging also it's there. That is the basic requirement. Then online status, when the user, the destination user, when the status of online and offline, that is also a requirement. And message delivery status, when the message is sent and delivery read, every status has to be done, every status has to be maintained. So that is what the functional requirement of WhatsApp. So what is about non-functional requirement? Non-functional requirement means it is required but not the not the basic, like it is required for the scale, like other things, like how the it will handle large number of users, and how so that part will be the non-functional requirement. Okay, so what are the points comes under non-functional requirement? That is high availability. Whenever any user wants to send the message, the system should be available. It should work at the same time. Whenever at any random time when a user wants to send a message to user B, then the moment the WhatsApp should be ready to get that and send it to the user. So that is what the high availability. Low latency means it should be fast enough, like the communication between the user and user A and user B, or any user A to any group. So that communication should happen very fast, and that is what the latency is, low latency. Okay, Scalability basically, like it is actually handles billions of users. So that is how this WhatsApp works. It basically handles a lot of users every day. Billions of messages are sending across WhatsApp. So that is how it is scalable, and it works, and it handles that much amount of users. So that is where the scalability is. Security, basically whenever messages are sending across the network, so that basically encrypted. Okay, when the user sends a message, it encrypted, and whenever user read the message, at that moment the message is getting decrypted. So security is also maintained in that communication. So this is these four points which are basically comes under non-functional requirement and functional requirement. That is the basic part of the application. Okay, that is how it divides. And that design architecture, like the diagram also we have understand. Now we will go to the components, how it works. So this particular video is basically theoretical understanding, like how the components handle each, and means what components handle what. Okay, so first one is the the mobile client. Mobile client means the the iOS or Android application where we are starting the communication for the send message, okay, or receive message. So this is actually mobile client means maintains persistent connection using the WebSockets. So basically it uses WebSockets to maintain a persistent connection. Okay, send and receive messages instantly. That can be happen because using the WebSockets, and handles retries for failed messages. It also retries for the failed message. For any reason, might be the message can be failed for any internet failure in between. Then whenever network available, it will retries that retries for failed messages which were not sent earlier. So that will be also taken care. The next component is the load balancer. Load balancer, the work of the load balancer is basically it distributes the traffic across multiple servers. So basically like as WhatsApp is handling a lot of billions of users, that is why it handles multiple servers. So the load, whatever request and response that need to be distributed across the servers, which is suitable. Let's say you are sitting in India and you want to send a message inside India, or whenever you want to send message to outside of India. It depends upon the location. So that load balancer will distribute that particular request and response and across the servers, so that it can be handled properly, and it can maintain the availability and all. So that is how it is. And prevents server overload. Also load balancer also works to prevent the to avoid the overload. That part also load balancer usually handles. The next is chat servers, the core of the messaging system. Basically it handles message routing, like in which location, like user the in between the users the message has to be sent, and that will be how it can be, even if the users are sitting long away. It doesn't depend where the users are there. It any corner of the planet the users can be available, so that messages should be sent across without worrying about the location. So that can be possible using this message routing. Okay, and depends upon because whenever any user has been created, it must be whenever user is created, there should be user ID, and every user ID is also that is how the location, how at that moment that is allocated to a particular server, like how that handles. So accordingly it will take care of that. Basically what happens whenever a user is created, and that usually dedicated some of the servers that is allocated, so that some of the communication will happen, like routing can be happen accordingly. Okay, so chat servers taking care of message routing, delivery acknowledgements. Message can be after the message is getting delivered, it will acknowledge to the the sender part. So that also happens. Temporary message storage, definitely whenever like temporary message storage also need to be taken care. That is like whenever any, let's say the one user is offline, so that moment it can be handled to keep some temporary storage, and sync it when the network will be available. So in that case, some temporary storage also need to be managed in the chat servers. Then presence servers basically it tracks the online and offline status of a particular user and the last seen when the user last online and last seen. So that kind of status can be handled by the presence server. Okay, it basically handles that part. And uses in memory storage, it basically uses in memory storage like Redis for last updates, some recent charts and all. That part can be handled by the Redis, which is in memory storage. So that is how I mean, whenever user is created, there should be user ID, and every user ID is also that's created, and that usually dedicated some of the servers that is allocated, so that some of the communication will happen, like routing can be happen accordingly. Okay, so chat servers taking care of message routing, deliver acknowledgements. Message can be after the message is getting delivered, it will acknowledge to the the sender part. So that also happens. Temporary message storage, definitely whenever like temporary message storage also need to be taken care. That is like whenever any, let's say the one user is offline, so that moment it can be handled to keep some temporary storage and sync it when the network will be available. So in that case, some temporary storage also need to be managed in the chat servers. Then presence servers basically it tracks the online and offline status of a particular user and the last seen when the user last online and last seen. So that kind of status can be handled by the presence server. Okay, it basically handles that part. And uses in memory storage, it basically uses in memory storage like Redis for last updates, some recent charts and all. That part can be handled by the Redis, which is in memory storage. So that is how like handles by the presence server. Okay, the next is message queue. Basically this part is also very important, like Kafka and RabbitMQ, that these systems are taking care of this message queue. This handles basically message delivery retries also, and buffering during the high traffic. So that basically when we are sending a lot of messages one by one after another, so in that moment because as per the system, if you imagine like it handles billions of users and every user sending messages one by one, so multiple messages are sending one after another. So that queuing, I mean message queue need to be handled properly, otherwise it cannot be delivered. Like each message has to be passed through the channel and it should be received to the receiver end. So that queue system need to be work properly. So that is how the Kafka and RabbitMQ handles all these things. Okay, this is very important, one of the important component of WhatsApp system design. Then the database, because basically the messages are very high in size, like the data in terms of data. So it need NoSQL database because to maintain the high write throughput and horizontal scaling. For that thing, NoSQL database is preferred. So Cassandra or DynamoDB is the database which is used by the WhatsApp system. Okay, those are basically stores messages, user data and media preferences. So those things has to be maintained by this Cassandra or DynamoDB. Why this NoSQL is preferred here? Because it need to handle high write throughput, and it need to handle lot of amount of data. Then Cache, like Cache is basically need to that recent charts and user sessions, that for that to handle Cache, I mean Redis is required. So that is also used. So let's understand a short if we see like how it is. A user A sends a message goes via WebSocket to chat server. Whenever a user A sends a message goes via WebSocket to chat server. Chat server validates the user, stores message in DB, pushes to message queue, right? So it will validate the user, stores the message in DB for any kind of like retrying purpose, and then pushes it to message queue. Message queue will handle that message queue will queue that message to send it to the receiver end. Okay, message delivered to user B if online, if offline, stored in the queue. If the user B is not online, then in the queue, so in the queue server, that will be stored in the queue, okay, delivered when the user reconnects. So that is how it works as well, delivered when the user reconnects, and deliver acknowledgement sent back to the user A. So that is how the system works in WhatsApp. Encryption, definitely messages are encrypted on sender side, and only a receiver can decrypt it, and a receiver cannot read the server cannot read the messages. So encryption and decryption happens at the user end. So that is how the security maintained in WhatsApp. There will be no read messages in the in the server side. So that only do the communication between user. It's only the transport the message from user A to user B, but that message read can only be happen at the client end, at the user A, at the user B. When a user A sends a message, it will only can be decrypted at the user side. Okay, that is how the security has been maintained in WhatsApp system. So yeah, and if you understand scaling, how scaling happens, basically horizontal scaling is basically need add more servers dynamically, whenever the users increasing in size in WhatsApp. Let's say today, for example, 1 billion of users are there for WhatsApp. Let's say tomorrow it will be 2 billion, for example. So in that case, the system has to be scalable, otherwise it can't be handle that amount of users. So that need a horizontal scaling, right? So we have to WhatsApp has to add more servers, more queue systems, more database. So that is what the horizontal scaling is. Okay, they have to add and maintain it. And partitioning, it is basically splits users across servers. That usually required, I have told you in the initial part, users some dedicated servers are aligned to users, so that it can be handled easily. Okay, the communication can be handled easily, so without worrying of always without the load balance. The load balancer has to distribute among some specific servers of specific users. That is how it works. Replication, replicate data across multiple nodes. Okay, that is also it's a scalable techniques. Okay, and CDN for media, store images and medias using CDN for faster delivery. So that is how the scalability works in WhatsApp. So these are some interview tips we have to take care of, for the real-time communication. WebSockets has been used, and message queue for reliability, because the message should not be missed in between. So the queue system actually ensures every message has been sent from the user A, and it will receive at user B whenever user B will be available. That is what the message queue for reliability it works. Okay, NoSQL DB for scalability, because NoSQL DB will handle large amount of data, so that is why NoSQL DB has been used. And load balancer will be distribute the request and response throughout the servers. That is how the load balancer works. And offline message handling, that also required whenever networks are not available. So WhatsApp has to cache and store that messages, and will be sent whenever it will be available. So that also need to be taken care. Okay, so this is how overall there are some advanced advanced enhancement, like typing indicator, message reactions. These are additional things, but basic part is this much. This is the basic part. Usually there are two users, user A and user B, or user A to a group. Okay, that is how WhatsApp works. And also these so these are the key components, mobile client, then WebSocket or TCP, that will handle the reliable connection between the server and the client, mobile device. Then load balancer will distribute the request throughout the servers, and the chat server will taking care of the message sending and receiving and acknowledgement, and Kafka RabbitMQ will take care of the message queue part. Then next come to this presence server will take care of the status, tracking the online and offline status, and that part will be, and the last online status, so that thing will be taken care of by the presence server. And cache will be the temporary storage which will be there to cache at whenever the communication happens, cache will taking care of temporary storage. And So whenever any communication breaks, immediately then Casa will take care of the recent charts and all. Okay. And database, definitely it is one of the most important part that will handle large amount of data. And okay, so this is how the overall system design of WhatsApp. We have understand all these components. It's a like theoretical concept, like how the system design of WhatsApp works. I hope you understand. And if you like this particular video, and please share to others and subscribe to the channel for this type of videos. Thank you so much for watching.